Everyone, and welcome back to my online teaching platform. We are still on application of differentiation, and we have our 10th question here. This is a question: the normal to the curve y is equal to x squared plus 6x plus 10 at a given point with x coordinate of -2 and y coordinate of +2 is parallel to the tangent to the curve y is equal to px squared plus qx plus 2 at a point with x coordinate of 1 and y coordinate of half. We are to find the values of p and q. All right. So let us identify the key concepts here. We have the first one to be parallel. Okay. So we have to know the relationship between two parallel lines. When two lines are parallel to each other, it implies that they have equal gradient. So from the given statement, the normal to the first curve is parallel to the tangent to the second curve. So it implies that the normal of the first curve and the tangent of the second curve have equal gradient. Okay, so we have to determine their gradient and equate the two gradients. So we start by finding the gradient of the normal to the first curve. All right, so we have our solution here. So the first curve is y is equal to x squared plus 6x plus 10. All right, and we have a normal to the curve at a given point, which is a point with a coordinate of x coordinate of -2 and y coordinate of +2. All right, so we know that whenever you have a curve, the tangent and the normal to that curve are perpendicular. So we can determine the gradient of the curve, which is the same as the gradient of the tangent. Then from there, we'll deduce the gradient of the normal from the gradient of the tangent to the curve. So let us first find the gradient of the curve at this particular point. So we know our gradient function to be dy dx, which will be equal to 2x plus 6. All right. And we are to find it at the given point. So we pick the x coordinate of the point, and we are going to substitute it into the gradient function. So we are going to multiply we are going to multiply 2 by negative x. Sorry, -2, which is the value of x, then plus 6. And this will give us a result of +2. So this is the gradient of the tangent at the point where the tangent touches the curve. All right. So we have to deduce the gradient of the normal from this. We know that the gradient of the normal, so we can say let m1 equal to gradient of the normal. All right. So we know that gradient of the normal, since we are using m1, times the gradient of the tangent to the curve must give us a result of -1 since they are perpendicular. So we make m1 a subject to y here. So we are going to divide through by 2, and that will give us a result of -1 divided by 2. Okay, so anytime you have the gradient of the tangent to the curve, to find the gradient of the normal, you just take negative reciprocal of the gradient of the tangent. The same thing applies if you have the gradient of the normal and want to take the gradient, you want to find the gradient of the tangent at that same point. You take negative reciprocal of the gradient of the normal, and that will give you the gradient of the tangent to the curve. All right. Now let us take our second function. Okay, because the gradient of the normal of the first function or of the first curve is parallel to the gradient of the tangent of the second curve, right? Is parallel to the tangent of the second curve. So let us find the gradient of the tangent of the second curve. So for the second curve, we have y is equal to px squared plus qx plus 2. And the tangent to the curve is at this particular point 1, x component being equal to 1 and the y component equal to half. All right. So we find our gradient function, and that will give us, to differentiate the function, we're going to get 2p plus q. And we are to, now we have 2px, sorry. The first term will be 2px plus q. So we have the x component of the point to be 1. So we substitute 1 in place of x. So we are now going to get 2p plus q. All right. And this is the same as the gradient of the tangent to the second curve. Now, in the first case, we solve for the gradient of the normal to the curve. That's from the first curve. Y is equal to x squared plus 6x plus 10. And we obtain the gradient to be negative half. Okay, we obtain the gradient to be negative half. Now let us look at the gradient of the tangent to the second curve, okay, which is equal to 2p plus q. It is given that the gradient of the normal of the first curve, or the gradient of the normal to the first curve, is parallel to the gradient, okay, sorry, the normal to the curve, that's the first curve, is parallel to the tangent to the second curve, okay. So since they are parallel to each other, they have equal gradient. So lines, so we say parallel lines have equal gradient. So since the normal is parallel to the tangent, they must have equal gradient. Okay, so the gradient of the normal is negative half, and it must be equal to the gradient of the tangent, which is 2p plus q. All right. So we need to work on our LCM. So we have to eliminate the fraction. So we multiply through by 2. So 2 times negative half is equal to 2 times 2p plus 2 also multiplying q. All right. So here we are going to get negative 1 is equal to 4p plus 2q. So we are getting our first equation to be 4p plus 2q is equal to negative 1. So this becomes our first equation. All right. Now this is a linear equation in two variables. The variables are p and q. So you need another equation before you can solve them simultaneously. So we go for the second function because the second function contains p and what? Q. All right. And there's a point on the function with x coordinate of 1 and y coordinate of what? Half. Anytime you have a point on a curve or on a line, the given point must satisfy the given curve or the given line. So from this point, our x is equal to 1 and our y is equal to half. So we will now substitute this component into the curve. So half is equal to p multiply 1 squared plus q multiply 1 and plus 2. All right. So you're going to get half is equal to p plus q then plus 2. Our LCM here will be 2. So we multiply through by 2. Half multiplying 2 equal to 2 multiplying p plus 2 multiplying q plus 2 multiplying 2. All right. So at the left hand side, we are going to get 1. Then equal to 2p plus 2q. Then, sorry, plus 4. All right. So we are going to get the result of, so we need to transpose the 4 with group like terms. 1 minus 4 equals 2p plus 2q. So here we are going to get negative 3 is equal to 2p plus 2q. All right. So we will name this as, let us rewrite it. We can bring it as 2p plus 2q, then equal to negative 3. Then this becomes our second equation. All right. So let us bring back the first equation. The first equation we had 4p plus 2q equal to negative 1. So we have 4p plus 2q equal to negative 1. So this is our equation 1. We just repeated the same equation. So we need to solve these two equations simultaneously. Now, you can see that the q in the first equation and that of the second equation have the same coefficient. Okay, so we can subtract. Okay, the sign in front of them are the same, positive, positive. So we're just going to subtract so that we can eliminate the q. So we can say that equation, either equation 2 minus 1 or equation 1 minus 2, you get the same answer. But I want to use equation 2 minus equation 1, right? So my equation 2 is 2p plus 2q equal to negative 3. Then minus equation 1, 4p plus 2q equal to negative 1. Okay, so I'll put the second one in bracket and I'll underline nicely, right? So we are subtracting the down one from the top. So 2p minus 4p will give us negative 2p. Then 2q minus 2q give us a result of 0. Then equal to, now we come to this side, negative 3 minus negative 1. You are going to get a result of negative 2. All right. Because negative 3 minus negative 1 becomes negative 3 plus 1. And we are going to get our new equation to be negative 2p equal to negative 2. So we need to make p the subject. We divide through by the coefficient of p, which is negative 2, right? So negative 2 will divide both sides, and that will give us a result of, so negative 2 cancels this negative 2. We are left with p, and we have here to be negative 2 divided by negative 2. We have the result to be 1. Okay, so the value of p is equal to 1. Now we have to now obtain the value of q. That is, so we just need to pick one of the equations. Okay, need to pick any of the equations to find the value of q. So I want to pick equation 1, right? So equation 1 is 2p plus 2q is equal to negative 3, right? So since we know the value of p to be 1, we just plug in the value of p into the equation. So we have to multiply the value of p, which is 1, plus 2p, sorry, is q rather, all equal to negative 3. So we are going to get 2 plus 2q is equal to negative 3. All right. So we make our 2p the subject, make our 2q the subject equal to, then we transpose the 2 to the right hand side. It becomes negative. So negative 3 minus 2. So we have 2q to be equal to negative 5. All right. We are looking for q, not 2q. So we divide through by the coefficient of q. All right. So we divide through by 2, here 2 by 2. And the result of q becomes negative 5 divided by what? 2. All right. So let us go through what we have done again. Let's use 2 minutes to go through it again. Okay. We have a normal to a given curve, okay, and a tangent to another curve. And it is stated that the normal to one of the curves is parallel to the tangent of the other curve. So we know that a normal is a straight line which is perpendicular to a tangent of that same curve. But in this case, we have two different curves, and we have a normal of one of the curves given to be parallel to the tangent of another curve. Okay, so what you just need to do is to find the gradient of each of the given uh, concepts. So we have the first concept to be the normal, right? So how do you determine the gradient of the normal to that particular curve? The gradient of the normal to that particular curve. You determine the gradient by finding the gradient of the tangent first. Okay, and we know that since the normal is perpendicular to the tangent of that same curve, you just need to take negative reciprocal of that gradient to determine the gradient of the normal. Okay, and that becomes the gradient of the normal to the first given curve. Okay, then the second curve has a tangent which is parallel to the normal. So what you are supposed to do is to find the gradient of the tangent of the second curve. Okay, so that one to find the gradient function, then you plug in the component of the point at where the tangent touches the curve, and you are going to get your gradient of the tangent. For this particular, you don't take any negative reciprocal of the gradient because that is the gradient of the tangent. Okay, so after you have obtained the gradient of the tangent of the second curve, there's a condition that the gradient of this tangent is parallel to the gradient of the normal to the first curve. So since they are parallel, the gradient of the two must be equal. Okay, so you equate the two gradient to get your first equation in terms of P and Q. So we have done that, and we obtain an equation. Here we have obtained this equation. So this is what we had when we equated the two gradients, and this became our equation one. All right. Then we consider the second part. So because we have a linear equation in two variables, we need two equations before we can solve for P and Q. Okay, so you just need to go for the second function because that is the function that contains P and Q. All right, and there's a point on the function with a coordinate x coordinate of 1 and y coordinate of half. So we just substitute those coordinates into the function so that you can get another equation in terms of P and Q because those coordinates are the coordinate of the point that lie on the given function. All right. So when you get the second equation, then you can now solve them simultaneously to get the values of P and Q. All right. So that's how you are supposed to answer this question. Thank you for watching. Please do not forget to subscribe to my YouTube channel and also share with others. Bye for now.